All right, Algebra 1 students, let's look at Unit 2, Lesson 9, Which Variable to Solve For, Part 2. So we're continuing what we were doing in the previous lesson. We have two goals here. Please pause if necessary to write this down, but I'm going to take you through them. I can write an equation to describe a situation that involves multiple quantities whose values are not known, and then solve the equation for a particular variable. Here's the idea. We're going to have two or more letters or variables in the problem. And we're going to have to solve the problem for one of those variables. Sometimes we might even solve it multiple times for different variables to get different looks at the equation. I know how solving for a variable can be used to quickly calculate the values of that variable. So the idea behind this is, if we solve this problem for one variable, we can then plug numbers into that problem and get answers for that variable we solved for much quicker than if we left the equation the way it was. So our goal here is actually to create a simpler problem to use. We're still working with the same main four vocabulary words. So we have equivalent equations. Remember, that's equations that are equal or have the same solutions to each other. Order of operations. Remember, we have our 4 steps. We start with our parentheses. We work with our powers or exponents. We then go on to division and multiplication. And remember, we always go left to right with that. We don't multiply first. We don't divide first. We just do whatever is first. Then our 4th step is the same as the 3rd step, just with addition and subtraction. We don't add first, we don't subtract first. We just do whichever one comes first, going left to right. Remember, we have our distribution rule about getting rid of parentheses and the big division bars and how we can divide or multiply to get rid of those. And then we have our balance rule. Any math that we add into the problem, we must do to both sides, whether it be addition, subtraction, multiplication. If we're putting that math in, it wasn't originally there, then we must do it to both sides of the equation. All right, so we've got this equation, v plus f minus 2 equals e, which relates vertices, faces, and edges in a platonic solid. Okay, we're going to use that equation for these next 2 problems, really 3 because the first one is split into 2 parts. I want you to write an equation that makes it easier to find the number of vertices in each of the platonic solids described. So the key thing here is we want to know vertices. So because of that, we want to take this equation and solve for v. We want to get v by itself. That's what it's saying. Once you have v by itself, you can plug some numbers in based off of the information here to create new equations. So the first one is an octahedron, which I've drawn here, which has 8 faces. So 8 faces, where would the 8 go? An icosahedron, which has 30 edges. Use that equation that you created. You're going to put 30 in for edges. All right, the second problem is a Buckminster fullerene, or otherwise known as a buckyball, is a polyhedron with 60 vertices. It is not a platonic solid, but the number of faces, edges, and vertices are related the same. So even though this buckyball is not a polyhedron, or is not a platonic solid, it still uses this formula. So we're still going to use that formula for number 2. Write an equation to find faces if we know edges. So we want to find faces. We essentially want to solve for f. Then we know 60 vertices. Plug that into the problem. All right, so you want to create those 3 problems, plug the numbers that you know in, bring those math problems with, because they will not give you an exact answer numerically, but you'll have 3 new equations. Bring those to class, and then that will start our discussion in class tomorrow. Thanks.